Hello everyone. In the previous class, we have discussed what are the various IT perspective on cloud computing with respect to various business organization, and also we have discussed cloud dynamic infrastructure and what are the various features that are present in the cloud dynamic infrastructure. Today we will discuss the essential characteristics of cloud computing based on NIST. Okay, based on NIST, there are five essential characteristics, that is on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. We will see each of these one by one. The first one is on-demand self-service. Okay, here a consumer can demand or use services offered by the provider without any prior intimation. Why this cloud is called on-demand self-service means among so many services that are offered by the provider, a consumer can actually use the required service without informing to provider in advance. The one requirement of this is there is no human intervention. All the resources requested are processed automatically. And the next characteristic is broad network access. This is a characteristic by which the end user can access all the computing resources over the network by various heterogeneous devices such as smartphone, tablet, thin clients, and thick clients. And we know that the cloud deals with huge amount of data where large computations are required. Hence a very high bandwidth has to be fulfilled by both provider and consumer. And the next characteristic is resource pooling. In case of resource pooling, all the resources are pooled together. That is storage, memory, network, bandwidth, all these resources are pooled together, which means all these resources are stored in a data center or in a multiple data center. In case of resource pooling, or the consumer can get the same service any number of times. Resource pooling will serve multiple consumers, which means which means there is a multi-tenant model in case of resource pooling. What is multi-tenancy means? A common infrastructure is being utilized by multiple clients. Say if you consider an example of an apartment where there are multiple clients and there is a common infrastructure. That infrastructure, the common infrastructure is there is a common space, there is a common swimming pool and a common play area. All these common infrastructure will be given to all the clients, where all the clients have equal access to that common infrastructure. In the same way, even in the cloud there will be a common infrastructure where all the tenants will have equal access to that common infrastructure. And here there is a all the resources are dynamically assigned and reassigned according to consumers demand. That is what a consumer can consume the same resource as many times based on consumers demand. And there is a location independency. All the resources, all the computing resources provided to consumers irrespective of where they are located. all the cons- all the consuming resources, that is the storage, servers, processing, network, bandwidth, virtual machines, all these are provided to consumers irrespective of where they are located, and the consumer will not be aware from which geographic location the services are being offered. And the next characteristic is rapid elasticity. So here, when you pull the elastic material, it will grow, and when you release the elastic material will shrink. How this how this how this elasticity is related to cloud computing means the amount of resource that is made available to the users should look unlimited to the users. Say when a user requests for a particular amount of resource. The provider will provide the required amount of resource without any concern whether the provider has that much amount of resource or not. Say for example, if you consider an academic institution, during normal semester days the storage resources are not needed much. When you consider during examination time, a lot of student data has to be stored in server, where storage will eventually grow depending on usage of server and shrink back to normal when not needed. In the same way, you can consider another example, that is the Zoom application is being used by many universities for online classes during this lockdown period, and hence the server has to handle lot of user requests and lot of workload will be handled by the server. In this case, the amount of server needed to do all these tasks may grow on demand and will shrink back when the usage of the application drops. The next characteristic is measured service. In case of measured service, all the resources used is measured by a metered capability. So all the amount of consumption of resources can be monitored, controlled, and reported by the cloud provider. And there is a transparency for both provider as well as consumer. A provider will come to know what are the amount of resources that are consumed by the consumer, and the consumer will come to know what are the various services that are offered by the cloud provider. The next concept is cloud adoption. Almost all organizations are adopting cloud or cloud services. Based on technical characteristics, cloud adoption is suitable for applications that are modular and loosely coupled. Modular means the software is developed on modular basis and the dependency between modules are very minimal. And workload isolation, an isolated workload means there are various types of workload. There are various application programs that is running in the server, that is one type of workload. And the number of users connected to a particular servers, so various users are interacting with the same application. All these workloads are isolated from each other, and a server has to handle all these workloads separately. And cloud can be adopted to develop a software. To develop a software, a cloud is providing a very good platform, and also to test a software, the cloud is providing a very good platform. And to do some R&D projects and to test new services and new applications, a cloud can be adopted. Again, the applications that need significantly different level of infrastructures throughout the day. Even in this case, the cloud can be adopted. The best example is Uber. Uber is using a cloud service where many users are accessing the Uber. Say, consider during peak hours, the Uber application is being used by multiple users. So during that peak hours, all the servers will automatically scale up to handle multiple requests. Why? Because if there is only one server handling all the workloads, then the performance may go down and there will be some downtime. So automatically the server will scale up depending upon the usage. And for the second one, applications that are used solely during business day. For this also you can consider the same Uber example. And the next one is application with seasonal demand. For this you can consider the Mintra. Mintra is an organization where it is also using a cloud service. Say during the certain special days, certain special holidays or certain festivals, or during end of the season, this Myntra application will be used by many customers. Again, to satisfy all the customer demands, the Myntra is also using a cloud services. Again, applications that need different level of infrastructure throughout the month. All these are the various cases that are the various cases where this cloud is being adopted. The next one is some of the organization will actually not adopt the cloud. Say in case an organization is using mission critical application. Mission critical application means the application will run continuously. So every time the application should run continuously. Suppose if the application stops for a while, then all the operations will come to an halt, which will cause a huge loss or a huge financial loss to an organization. So some of the financial organization may not adopt to this cloud. Why means they want their data to be stored within their organization. For that reason, they are using their own servers to maintain accountability and auditability.